Earlier for this unit, we had discussed the naive model and the seasonal naive model, as well as some other smoothing methods. So what we're going to do here, I think this is helpful. Let's take the data that we have and create a different model for it. So we created a multiple linear regression that tried to capture a linear trend and additive seasonality and came up with a MAPE of 6.1%, a MAD of 1.94, etc. So what I want to do now is and this is always a good idea actually, is to use a naive model as the baseline and see if the model that we came up with the multiple linear regression is any better. If it's not, then we've wasted our time coming up with a more complex model. So we're going to, because we think there's seasonality to this, we will use a seasonal naive model, which says, I think the quarter for next year, quarter one for next year, is going to look like the quarter one that happened this year. Quarter two for next year, I think, is going to look like the second quarter for the current year, or the most recent year that we have data for. So let me do the following. I'm going to take the data and put it on a new worksheet. So I'm going to go ahead and grab all this stuff, even though we don't necessarily need it. And I only want to go up to 48 because that's the actual historical data we have. The other stuff, right, there's no data for it. So I'm going to copy that, create a new worksheet, and paste it over here. All right. So now what I can do is, really I don't need this time period index in these quarters, so I'm going to go ahead and get rid of those. I think it'll make our life a little bit easier. Not much, but a little bit. Alright. And then I want to create a column called forecast. And then I might as well do my error term, my absolute value of the error term, absolute value of the error term divided by the actual, and the error term squared to get those metrics that we're going to compare it to. And I'm going to go ahead and drag this guy over to the end and call him seasonal naive. Right. So because I'm doing quarters, I can't have a forecast for the first one because I don't have any quarter one from 1998, right? So the first time I can make a forecast is in the first quarter of the second year, so the year 2000. And that would just be pointing to what I saw in quarter one from the year before. So I'm going to do that. And then in theory, I ought to be able to drag this guy down all the way, if I could go in the right direction. All right. And I lost how far down I went, which is okay. And notice that I can, doing a seasonal naive, I can forecast out however many seasons there are within a year or whatever time period we're looking at. I can forecast out that many into the future. So I can forecast out a single year using the seasonal naive for this particular data set. I can forecast out 4 quarters. All right. Beyond that, you saw that it turned to 0 because there's nothing there. So the error terms, remember, only exist when there's an actual and a forecast. So we take the actual, subtract out the forecast, and then take the absolute value of the error term, take the absolute value of the error term, divide by the actual, and then square the error term. And now I ought to be able to do all of these. And we better go down and look, because notice down here at the bottom, because I had forecast out there, it tried to do this stuff. So I don't need those at all. So I want, this will be the MAD, the MAPE, the MSE, and the RMSE. So it'll be the average over absolute values All right. And take the square root of that guy. This is a percentage, so let's make it a percentage. All right. Now let's compare to what we had before. So a MAPE of 8.49%. Where do we have that on data? The MAPE was 6.1% for the linear regression model. For the seasonal naive, it's worse. MAD is also bigger, so seasonal naive is not as good. MSE for linear regression, 6.62. For seasonal naive, 11.7. So then that means the RMSE is also going to be bigger for the seasonal naive than it is for the multiple linear regression. So our baseline of the seasonal naive is not as good as our more complex model. So that tells me that there is some value to doing a multiple linear regression for this particular data set to help me forecast into the future. Not only that, but with the multiple linear regression model, I can forecast farther out into the future than I can with the seasonal naive model.